Example 1.8. An electron falls through a distance of 1.5 centimeter in a uniform electric field of magnitude 2 into 10 to the power 4 Newton per coulomb. The direction of field is reversed, keeping its magnitude unchanged, and a proton falls through the same distance. Compute the time of fall in each case. Contrast the situation with that of free fall under gravity. First, we will see what are the given values. That is, distance S equal to 1.5 centimeter. Electric field is 2 into 10 to the power 4 Newton per coulomb. Charge on electron is known to us 1.6 10 to the power minus 19 coulomb. Mass of the electron and mass of the proton is also given. Now, first step is, what is the expression for force? Force in the case of electric field, F equal to charge into electric field. According to Newton's second law, F equal to ma. If we equate those two, that is acceleration A becomes F by m or F equal to QE by m. Now, how to find the time? We'll use second equation of motion, S equal to ut plus half at square. Initial velocity 0, therefore S equal to half at square, or time limit t equal to root of 2s by e. Okay. First case for electron, we are using this formula, acceleration equal to QE divided by m. Mass, charge of the electron 1.6 10 to the power minus 19 multiplied with the electric field 2 into 10 to the power 4 given in the question, divided by mass of the electron 9.1 10 to the power minus 31. After simplification, we are getting acceleration of the electron is nearly 3.5 into 10 to the power 15 meter per second square. What is the time taken to cover this distance? T equal to root of 2s by a. 2 into s value is 1.5 10 to the power minus 2 divided by acceleration produced by electron. We have calculated here 3.5 into 10 to the power 15. If you simplify this, nearly you are getting 3 into 10 to the power minus 9 second. This is for electron. Same way we'll go for proton now. Mass of acceleration produced by proton equal to E by mass of the proton. Charge is same for electron and proton. Magnitude of charge is same. So 10 to the power 4, 2 into 10 to the power 4 divided by mass of the proton 1.67 10 to the power minus 27. If you simplify, you are getting 1.9 into 10 to the power 12 meter per second square. Same way, we'll find out the time required for the proton to reach the other side. That is root of 2s by a. 2 s is same divided by acceleration of the proton. This is the acceleration of the proton we are substituting here. So we are nearly getting 4 into 10 to the power minus 7 seconds. So we got acceleration of the electron and time taken by the electron. Same way, acceleration of the proton and time taken by the proton. Now the last part of the question. Contrast the situation with that of the free fall under gravity. Now see, proton is having larger mass. So acceleration produced mass is more. Therefore, acceleration produced by the proton is less. Electron is having smaller mass. Therefore, acceleration is more. Acceleration produced for electron is more. But if you take gravity, only under the effect of gravity, A equal to G if you take, electron and proton both will fall in the same time under gravity, because even though different objects are having different masses, all those bodies will reach the ground in the same time under the effect of only gravity. Electric motion depends upon mass, but gravity does not depend upon the mass.